systems are an important prerequisite for mobility and quality of life. Innovative mechanized tunneling technology from Heron Connect paves the way for this, economically, quickly, and safely. Single and double shield tunnel boring machines, TBMs for short, are the ideal machines for tunneling in both stable soils and hard rock. The basic mode of operation of both machine types is described in the following, and the differences in individual functions explained. Both TBMs have a shield skin that serves as rock support until the tunnel lining is installed. With the double shield, this shield skin is divided into a front and a rear shield. To loosen the rock, a rotating cutter head equipped with disc cutters is pressed against the tunnel face at high pressure. The contact pressure exerted by the disc cutters causes individual pieces of rock, known as chips, to break out of the rock mass ahead. Water jets installed on the cutter head reduce dust formation and cool the disc cutters. Optionally, integrated sensor systems aid early wear detection. This facilitates the planning of efficient maintenance intervals for disc cutter replacement. Bucket scrapers pick up the cuttings. Due to the rotation of the cutter head, the material slides over chutes to the center. There it falls through the muck ring onto the machine belt running to the rear, from where it is transferred to belt conveyors and transported out of the tunnel. The excavation diameter of single shield and double shield machines is larger than that of the shield skin. Furthermore, the boring axis of the cutter head is offset upwards in relation to the machine axis. The resulting overcut enables optimum control of the machine. Hydraulic stabilizers in the front shield area are pressed against the tunnel wall and stabilize the machine during the advance. This reduces vibrations and wear. Various drive concepts are available for tunneling with single shield and double shield TBMs. Depending on the requirements and diameter, either permanently installed drives with steering cylinders or torque box drives are used. The torque box cylinders allow infinitely variable horizontal and vertical adjustment of the drive. If the rock tends to converge, the excavation diameter can be increased by extending the gauge cutters and installing additional overcutters to prevent the shield from jamming. In addition, the cutter head thrust force can be precisely monitored via the hydraulic cylinders. With all drive types, the cutter head can be retracted. With a double shield TBM, even up to a full stroke length. Inspection of the tunnel face is possible. The disc cutters and buckets worn during the boring process can be replaced easily and safely from the rear under the protection of the cutter head. The tunnel is driven under the protection of the shield skin, which serves as rock support until the tunnel lining is installed. The final securing of the tunnel is usually carried out with precast concrete elements, the lining segments, which are installed under the protection of the shield skin. The interior of the TBM and the tunnel crew are always protected against the surrounding rock mass. The lining segments are picked up with a hydraulic manipulator, the so-called erector, and positioned to form a complete ring. For this purpose, the thrust cylinders are retracted at the respective installation point. The segment is set in place and held in position by extending the thrust cylinders again. The key segment placed last completes the ring building. The next tunneling phase can begin. As soon as the shield is pushed forward in relation to the tunnel lining, an annular gap is created between the rock mass and the segment extrados. This is continuously backfilled with mortar or pea gravel as the machine moves forward. Double shield TBMs have a split shield skin. Behind the front shield, there is an additional gripper shield. The gripper unit, the auxiliary thrust cylinders, and the tail skin are located here. The main thrust cylinders connect the two shield sections with each other. A shield telescope protects the thrust cylinders and the inside of the shield from the sidewalls of the tunnel. During regular tunneling in undisturbed rock, the machine braces itself radially in the tunnel with the gripper shoes. The front shield and the cutter head can now be advanced independently of the gripper shield using the main thrust cylinders. The reaction forces occurring during boring are transferred into the rock by the gripper shoes. Tunneling and the installation of the segments in the tailskin can be carried out in parallel. The auxiliary thrust cylinders are used to secure the position of the installed segments. The single shield TBM does not have a gripper shield. The reaction forces from the boring process are transferred via the thrust cylinders to the segments. Once the advance cycle is complete, the gripper plates are retracted and their gripper shield is moved in the direction of the advance. This repositioning phase only takes a few minutes. This enables practically continuous tunneling in fault zones or areas with low rock strength that do not allow the gripper plates to be braced in the rock. The telescopic shield can be completely retracted. The front and gripper shield thus form a rigid unit. The required feed forces are applied via the auxiliary thrust cylinders. The segment ring built last serves as an abutment for support. This discontinuous mode increases tunneling safety in difficult sections and allows adaptation to changing geological conditions. A time-lapse illustrates the different working phases of the two TBM types. With the single shield, the tunneling phase and the ring building phase continuously alternate. With the double shield, both phases can run in parallel in stable rock, enabling high advance rates. In this way, the finished tunnel grows ring by ring. With the help of advanced ground improvement, it is possible to extend the geological area of application. For example, water ingress can be reduced to a manageable level. Drill rigs installed on the TBM are used for this purpose. Fissures can be filled and mountain water ingress reduced by means of injection drilling through the shield. With the double shield, it is also possible to raise the telescopic shield to access the tunnel intrados and carry out rock improvement measures. Dewatering systems pump out the water as it enters in a controlled manner. The supply of the tunneling machine is provided in the backup area. The steel structure contains hydraulic units, pumps, control cabinets, ventilation systems, and laser measurement technology, among other things. Recreation, office, and rescue containers for the tunneling crew are also housed here. The handling equipment for transporting the segments to the site and for removing the spoil is integrated here too. All key information and current tunneling parameters come together in the central control container. There they are visualized on monitors and provided to the machine operator. He can monitor the largely automated processes and take corrective action if necessary. Thanks to their simple tunneling principle in combination with the wide range of applications, Heron Connect single shield TBMs are real all-rounders for tunneling in solid rock. Heron Connect double shield TBMs are the ideal choice for tunnel projects with changing rock formations. In stable rock, they achieve very high advance rates thanks to the continuous tunneling mode. The technology is therefore often the fastest and most economical solution for long hard rock drives.